In this lesson, we're going to be talking about the mean proportional theorem. This is going to be a lesson that is comprised of two different things. So today, we're just going to be talking about the altitude rule. So if we're talking about the altitude rule, you got to know what an altitude is. So some prior knowledge is that an altitude is a segment drawn from the vertex that meets the opposite side at a 90-degree angle. So in other words, we know that our altitude is perpendicular to the side that it's touching. Now, what we're going to be studying in these next couple of lessons is we're going to be starting with a right triangle. And in our right triangle, we got to be mindful of the sides, right? We know that the side across from the right angle is the hypotenuse. I think I butchered that. Oh, no, I spelled it right. Hypotenuse. And then the other two sides here, these are all called legs. So we're going to need to know that. You want to make sure you're writing this down and labeling the hypotenuse and the legs so that we don't forget as we move forward. What we're going to be studying is we're going to be drawing an altitude from the vertex to the hypotenuse. And again, obviously we're creating those right angles, but we're going to be evaluating some patterns that we notice. We're going to be creating 3 different triangles, and all of those triangles are going to be similar to one another. So we're going to be using this to help us solve for some stuff. Now, getting right into an example, I just want to start by saying that we can solve all of these problems just by using our knowledge of similar triangles. Again, we always emphasize that you want to draw your triangles separately and make your proportions. Now, you can totally do that with lessons like these, but you are going to see why we do not recommend it. So let's just get right into an example like this. So AD is equal to 8. DC is equal to 18, and we are looking for the length of BD. So obviously, whatever we are looking for in our diagram, you want to go ahead and label that in as X, just so that we can get more of a visual understanding of what's happening here. Now, the question should say this, but BD is an altitude drawn to the hypotenuse. Now, what you should notice is that there are 3 triangles that are created here. Now, the largest triangle, let's do in this purple color. The largest triangle is triangle ABC. And you should be drawing this out. You should write largest triangle, draw out ABC, and let's carry over what we have. So we have a right angle at B, and then we know that AC, which is the value of our hypotenuse, is going to be 26. Now we also have a really tiny triangle that's created, our smallest triangle, and I should be doing this in a different color. Let's do it in a bluish teal color. Our smallest triangle is right here. Now, before I even go any further, I forgot to do something. When your angles are shared, you want to label that. So I know that angle A is going to be in at least 2 of these triangles. And I know that angle C is going to be shared by at least 2 of these triangles. So we want to go ahead and label that, and we should do that in our largest triangle as well. A double arc on A and a single arc on C. Because that's going to help us draw our triangles in the same orientation, which is what we want to do so that we can create our proportions, right? So our smallest triangle, we're just going to draw a triangle that looks like it first, and then we will worry about the letters later. So I know I want it drawn in the same orientation as this one. So my right angle should be up top, and in my smallest triangle, that is letter D, right here. Then I know that I want my double arc, because in my smallest triangle, I don't have the single arc angle, which is okay, but I do have that double arc, and we want that in the bottom left, and that's going to be letter A. And then we are only left with one other option, which is letter B. And we want to go ahead and fill in everything that we can. So AD, in this case, is 8, and we have that DB is X. And we don't have anything about AB, so we can move forward. Now, in this greenish color, I will highlight the medium-sized triangle that is created here. So medium triangle in green. Again, I'm just going to draw the triangle and worry about the letters after. So again, I want it to match up with the same orientation as these 2. So my right angle is at the top. That is letter D. Now, in my green triangle, I do not have the double arc, which is totally fine, but I do have that singular arc, and we want that singular arc in the bottom right, which is letter C, and then we are only left with one other letter. We got letter B there. Now let's carry over our labels. DC is 18. BD is X. Wonderful. Now, what you'll realize is that when you do this method, you're only going to need to use 2 out of the 3 triangles. Now, if you look at your largest triangle, you do have the value of the hypotenuse, but you have nothing about the other 2 sides, and we're looking for x. X is not even involved in the largest triangle, so you're going to want to go ahead and just cross that out. But don't do it in your notes, but you can just write not using in there. Don't actually like cross it out, just write not using. Now, using our knowledge of similarity, right, we know all of these 3 triangles that are created are going to be similar to one another. So we can make our proportions. Now, we can make our proportion using any method we're comfortable with. I like using the method where we bounce back and forth. So I'm going to do 8 over x equals x over 18. Then if we cross multiply here, we're going to get x squared equals 144. And then if we take the square root of both sides, we're going to get that x equals 12. Now going back to our diagram, x represented BD, which is what we were looking for, right? So BD equals 12. Now if you time that out, I didn't time it out, but it took us a long time to do, but we are able to do it with the knowledge that we already have. But we're going to show you an easier way. So this altitude rule is part of the mean proportional theorem, and it's actually a formula. So take a second to write this formula down. So we have when an altitude is drawn to the hypotenuse of a right triangle, we can use this formula to help us solve for missing pieces. So again, our right triangle is here, right? We are drawing that altitude down to the hypotenuse down here. Now, what you should notice is that this entire hypotenuse is being broken up into 2 pieces. So the first piece is right here, and I'll label that as P1, right? That's part 1 of our hypotenuse, right? Our altitude is obviously right here. And then from our altitude, this is the second part, part 2 of hypotenuse. So if you want to write part 1 of hype equals over altitude equals altitude over, you can write part 2 of hype, if that helps you. But this altitude is breaking our hypotenuse up into 2 pieces, and we can use that in our formula. So compare the times. We're going to do the same exact question, just using this method. So AD is 8, DC is 18, and BD is x. Now we want to make sure, and you can go quicker with this as you practice, but we want to make sure we're identifying our pieces. So this piece here, I'm using that as part 1 of my hypotenuse. This is my altitude. This is my second part of my hypotenuse. So let's go ahead and substitute those in. So part 1 of my hypotenuse was segment AD, which is 8, over my altitude, which is BD, so we can write x in for that, equals our altitude again, over the other part, the second part of our hypotenuse. Bam. When we cross multiply, we get x squared equals 144, and if we take the square root, we will get 12. So BD equals 12. Bam. If you compare the times, I guarantee you that was like at least 50 to 60% shorter. Now, the reason we want to use these shortcuts is because on your Regents exam, you don't want to spend 10 minutes on a question that could take you 30 seconds, right? So we're going to go over how to like identify when to use this, because in the second day of mean proportional theorem, you're going to have different information. But in general, what you want to look for is highlight your given information. Now, what I mean by that is we're given something about AD, we're given something about DC, and we're looking for BD, right? So if we highlight AD and we highlight DC, and then we highlight BD, which is what we're looking for, we kind of create this upside down T shape. It also looks like the perpendicular symbol, right? We kind of create that pattern. And when you see that pattern, you know you're going to be using the altitude rule here. Now, depending on, like this triangle could be flipped around, so you might not always be making a perfect upside down T. Depending on the orientation of your triangle, maybe you're making a sideways T like this. Maybe your T is right side up. Now, it depends, but generally when you see this pattern, when you highlight your given information and highlight what you're looking for, that's when we're going to be using this altitude rule. Now, this is an example where our orientation is slightly different, so let's get right into it. In the diagram below of right triangle ABC, altitude BD is drawn to hypotenuse AC. So here is my altitude, and it tells us that AC is 16 and CD is 7, and it wants the length of BD. So whatever we're looking for BD, put that as X in your diagram, and I'm going to highlight what we are given. So we're given that this is 7. I know I'm looking for this, so I'm highlighting that because it is involved. Now, I don't have the other part of that t, but we can use our given information to help us. So we know that the entire thing is 16, and this is 7. So that means that this piece right here is going to be 9. So now I can highlight it because I have it. So here I've kind of created a regular t. And this is telling me, hey, I know that I'm using this altitude rule, right? Now, if we want to go ahead and label, I know this is my first part of the hypotenuse. This is my altitude. This is the second part of my hypotenuse. So if we go ahead and substitute these things in, we get 7 over x equals x over 9. And if we cross multiply this, we get x squared equals 63. Now we have to take the square root of both sides, so we'll get x equals radical 63. Now we have to get comfortable with writing things in simplest radical form. So if you have this, what you want to do is, obviously if you put that in your calculator, you're going to get a crazy decimal. We don't want crazy decimals. We want to be able to simplify our answer as much as possible. So what we do here, we can create 2 branches. Now let's just pick 2. I know that 9 and 7 are going to multiply to 63 because we just did it here. So if you write radical 9 times radical 7, right, you can break that down. That radical 9 can break down into 3. That radical 7, I don't think we can break it down much more. But here, we get x equals 3 radical 7. Now, when you plug that in your calculator, you should get the same number. I don't have a calculator on me, so I'm hoping this is the right answer. But you want to make sure if you get a crazy radical with crazy decimals, that you break down that radical by making 2 numbers, or picking 2 numbers that multiply to it with that radical symbol in front. And then there should be one of them that you can take the square root of, right? So radical 9 is actually equal to a number, so we can just write 3 there instead and break that down even more. But this radical 7, we can't really break it down anymore. So here would be our answer. X, well, it should actually be BD equals 3 radical 7. Okay? So you want to make sure you understand when to use the altitude rule, what the formula actually is, and then you also want to be comfortable in writing your answers in simplest radical form.